Hi guys, this is Kumar. In the last video, I discussed a question with you, which basically works on how to use the sum of first n terms. So this is the question. So we had Donald Duck and Mickey Mouse competing in a 10,000 meter race. Mickey Mouse runs at a speed of 125 meters per minute. So let's write down the important points as we go along with the question. Total distance is 10,000 meters. The speed of Mickey, or rather let's write speed of Mickey rather than Mickey's speed. Speed of Mickey is 125 meters per minute. So the total time that Mickey will take will be nothing but 10,000 by 125. This will come out to be around 80 minutes. Alright. For Donald, the speed is 100 meters per minute, which means his total time that he will take is around 10,000 divided by 100, which is 100 minutes. Okay, so what you can understand is that Mickey is can finish the race much faster than Donald, and he can finish 20 minutes earlier than Donald. Now, what Donald needs to do is he needs to get rid of Mickey for 20 minutes. How can he do that? He can basically, okay, so he has a controller, and this controller can make Mickey Mouse run backwards. When the nth order is issued, Mickey Mouse will run backwards for 1 minute at a speed of n multiplied with 10% of its original speed, and then he will run backwards again at the original speed. So let's understand what has been said in this question. It is very important to write it in mathematical format. Let me see what happens when Donald issues the first order. So Mickey Mouse is running backwards. How much distance he is covering? He is running at a speed of 1, which is the first order, multiplied with 10% into the original speed, which is 125 minutes per meters per minute. So this comes out to be 12.5 meters per minute. So in the first second, suppose if this is the starting point where Mickey and Donald are starting the race, this is the finish point. So in the same second that Donald is actually running forward 100 meters, Mickey is going back 12.5. Okay. Now when the second order is issued, and the best way if Donald wants to win in minimum time, he wants to be issuing consecutive orders. So in the second order, Mickey is going to go back further. This comes out to be how much? So 1, 2. This comes out to be 25 meters, and he'll be covering at a speed of 25 meters per minute. He'll be going back 1 minute, so basically he'll be covering 25 meters. So now we are getting an idea of what is actually happening in the third, fourth, and fifth orders. Mickey would be going back. I just keep on adding 12.5, so this is 37.5 meters per minute. This becomes 50, and this becomes 62.5 meters per minute. Okay, now see, we need to get rid of Mickey for 20 minutes. Okay, now how this is being done, let's again see this as an initial point. Now after every minute Mickey is going back, right, and this distance is increasing. So let's say this is the first order, let's say this is the second order, let's say this is the third order, and let's say this is the point where the nth, or the, let's say, the last order is issued, right? Now what he'll do, as soon as that order is issued, he'll start running forwards to first reach the initial point. Now see, when the orders were being issued, he was running back 1 minute every time, right? It means that up till this nth point, n minutes have already elapsed, right? N minutes has already gone. Now what uh, what Donald wanted, like the total time that Mickey takes from the initial point to go back and come back to the initial point, that should be greater than 20 minutes. Okay, because if that is equal to 20 minutes, they will be reaching at the same time. Okay, the time that Mickey takes to go from here to here back, so the last point that he was there coming back to initial point, is basically this distance x by 125. So x is the distance, let's say, back to the initial point, and 125 is the speed. Now now what we need is that, or what Donald needs is that n plus x over 125 should be greater than 20, right? Now this n is what we have to calculate, right? What is this x? How do we find this x, and how do we find in terms of n, so that we can actually go ahead solving this equation? Okay, now x is nothing but the total distance he's going back, right? Total distance that he's covering. Remember, this is the time, this is not the distance. The total distance is x. Okay, so that would be equal to 12.5 plus 25 plus 37.5 plus 50 plus 62.5, going all the way up till 12.5 into n. So let's first calculate x, and then we'll put that back into the equation. Okay, so first he's going 12.5 meters back, then he's going 25 meters back. So let me write that as 12.5 into 2, then it's 12.5 into 3. It goes all the way up till 12.5 multiplied with n. All right, I can take this common, and this comes out to be 1 plus 2 plus 3 plus 4 all the way up till n. So this is the formula that I was talking about, the sum of n terms. This is where you need to apply. This is equal to 12.5 into, if I use the formula for n, sum of n terms, this is n into n plus 1 over 2. Okay, so remember this formula. This is very useful. If you want to know the proof of this formula, you can share. You can tell us in the comments, and we'll share the proof. Okay. Now let's come back to the equation that we were having. So I was having that my n plus x over 125. So my x is 12.5 into n multiplied with n plus 1 over 2. This whole thing divided by 125 should be greater than 20. Okay, so I'll do a little simplification. This I know can cancel out as a ratio of 1 by 10. So what I'm getting eventually is n. So 10 and 2 multiplied is 20. n plus n into multiplied with n plus 1 over 20 is greater than 20. All right, and let's simplify a little more. So I'll get 20n, if I take the base, if I make the denominator same, n square plus n over 20 has to be greater than 20. All right, I'll continue the simplification on the next page. So this comes out to be, let's see what all we had. We had an n square, we had 21n, and then we have n square plus 21n by 20 is greater than 20, and therefore n square plus 21n has to be greater than 400. All right, now n into n plus 21 has to be greater than 400. Okay, now this is a quadratic inequality, and that can be solved using the quadratic inequality methods, because it is a little complex for most of the students who are watching. So we'll share a simpler method that you can usually use to check and get the value of n. It's a basic hit and trial method. If you are interested in finding out what is the quadratic inequality method, you can let us know in the comments, and I'll share it. Okay, so let's see, how about we start with a guess. Let's start with n equal to 10. Let's say 10 is the minimum number of orders. For that I get 10 into 10 plus 21, which is 31. This is 310. Greater than 400? No. Okay, so let's try something bigger. What if we try n equal to 15, right? So this comes out to be 15 into 15 plus 21, which is 36. This will come around to be 540. Okay, so this is way off. I need to check if I can get for something lower. Let's go for n equal to 12. So I'll have 12 multiplied with 12 plus 21 is 33. This will come around 396. Now see, we are very close. Even though this is not acceptable, we are very close. And if n equal to 13 goes for n equal to 13, we get higher than 400, then that is qualified. So n equal 13, 20 plus 13 is 34. This comes out to be 442. We have a winner, right? So n is equal to 13 orders is the minimum at which Donald is going to win. For anything greater than that, he's obviously going to win, but for n equal to 13, he is going to win. So this is the list of questions that we are going to discuss next. Read the chapter of exponents, study these two, try to do these two questions, and I'll see you in the next video. Bye.